Okay, so this question looks at an object. It says we have a weightlifter that is lifting a 100 kilogram mass from the floor to a vertical distance of roughly about 2 meters above the floor, and it's going to do it slowly. And then he's going to let it back down on the floor again. And so we're going to find the work done by the weight, work done by the lifter, and then the total work done. So let's do our best to draw a picture of this scenario, right? So we have our object that is 100 kilograms. And then we're going to have our weightlifter that is going to lift on either side. So it's going to start there. And then our weightlifter, whoopsie, will have our object up above his head. And 100 kilograms there. And we've, moved 1.9 meters. Now, if we look at the forces, we're going to have the weight or the force of gravity pointing down, and then we're going to have the lift force pointing up. And what I would say is that those two forces will be equal for the fact that when it says it's going to move slowly, I would interpret that as a constant velocity. And so with a constant velocity, we know our acceleration then is 0, and we also then know that our net force is also 0. So from the sum of my forces in the y direction, we have our force lift minus our force of gravity, and that equals mass times acceleration. This is 0, and so then our lift force is equal to our force of gravity, or our weight. So let's look at the different parts. It says, first, find the work done by the weight of the mass on the way up. So as it's moving upwards, so find the work by the weight, or another way you could think of it as gravity. So gravity is applying a force downwards. We have a displacement upwards. And so our equation, which is work equals force times distance cosine theta. In this case, our theta is going to be 180 degrees, right? If we were to redraw our scenario, here's our object, right? Our displacement, S, is that direction. Our force is that direction. So that's 180 degrees between the two. Remember, we can slide individual vectors, so I could redraw this S vector here, and this is the angle that we're looking at. That's our theta. So with this then, I can simply say, okay, well, my work, let's do it down here. My work is going to equal the force of gravity times the displacement times basically -1. That's going to be mass times gravity times my displacement times -1, which is going to equal 100 kilograms. Gravity we'll just plug in as 10. My displacement is 1.9, and then multiplied by a -1. So what we have here, we have 100, 1,000. So that's going to give me -1.9, oops, sorry, not 1.91. 19, and then we move our decimal place 1, 2, 3 Newton meters. So that's the work done by the weight, or the work done by gravity, is -1,000, or excuse me, -19,000 Newton meters. The second part says find the work done by the force exerted by the weightlifter when lifting the weight. Well, from what we said earlier, we know the force is going to be the same. Our displacement is going to be the same. The difference with this now is, so we'll find the work by the lifter. So that's going to be work equals force times displacement cosine of theta. Now in this case, if this is our box, we have a displacement up and we have a force up, and so my theta in this case is going to be 0 degrees, which that's going to equal 1. So Work then is just the force of the lift times the displacement times 1. The lift force is gravity, so it's just mass times gravity times my displacement, and that we can cut ahead to 19,000 Newton meters. All right. And lastly, the third part, it says, what is the total work done by the weight on the way up and on the way down? So we can talk through this. What's going to happen is that weight is going to, well, let's look at our picture up here actually. We know that on the way up, the weight from here to here, the weight has negative 19,000 Newton meters. And on the way back down, guess what? The force of gravity is going to stay constant. The displacement is going to be just in the negative opposite direction. And so my work done should be a positive 19,000, and so really it should be a total work done of 0. So C, we'll find work total of the weight, or again, that's the idea of gravity, for up and down. So again, up, what we have our object, we have our displacement, we have our force, and we said that that was negative 19,000 Newton meters. On our way down, we're going to have now our object starts here. It has a force of gravity here. It has a displacement down now, and so those are going to be in the same direction, so that's going to be a positive work. And so the work net, or the work total, is the work up plus the work down, which is going to be equal to 0 Newton meters. And we'll talk about why that makes sense, but really the reason is because this makes sense in terms of the change in kinetic energy of the box is 0. Right? It starts with no kinetic energy, it ends with no kinetic energy, so the change in energy is 0, which means because we know that work equals a change in kinetic energy, if our change in kinetic energy is 0, our work must also be 0.